Okay, hi guys. So your homework is the same problems we already did in class. I just want you to redo those proofs and re just practice them so that you can get stronger in the proofs with quadrilaterals. All right, it says in the diagram ABC is a parallelogram and BD is a diagonal. Write a two-column proof to show that AB and CD are congruent. Okay, so here's what we're working with. We are going to first mark up what is given, and they told us this is a parallelogram, and they said BD is a diagonal. If BD is a diagonal, then here's what we can say. We can say that these two sides are parallel, and if BD is a diagonal, it's giving us a whole lot of information. Right here, then this is a transversal. If that's a transversal, then what that is saying is the this angle is the same as this angle, and this angle is the same as this angle, and that's alternate interior angles. That diagonal also is what we call a reflexive side. So this side BD is shared by both of these triangles, triangle ABD and triangle BCD. And it wants us to prove that AB and CD are congruent. So it wants me to prove this is congruent to this. Well, this is just going to fall on these proofs that we already know. So we're going to do a two-column proof. And we're going to have our statement and then our reason. So statement, then our reason. Number one is the given. And it says that A, B, C, D is a parallelogram. And I'm going to write shorthand. I'm going to go ahead and write it. It's a parallelogram. And it's also telling us that BD is a diagonal. All right, and that is the given. You can write the given on more than one line. So number two, and we can go and say that line segment AB is parallel to line segment CD, and our reasoning is going to be that's the property of a parallelogram. And I'm writing shorthand. You can fill the word out. Once we made that decision, then we can go and say that BD is a transversal. Well, we don't really have to say BD is a transversal, but what we can say is that angles, you can say the measure of angle, we're going to do the three-letter angle. So if we have B here in the middle, I'm going to write B in the middle, and the loop is facing AD. So I'm going to say AD is going to be congruent to this angle down here. So my D to the measure of angle, D goes in the middle, and BC are the same, and so is, I'm going to go here, D, the measure of angle, D goes in the middle, and I'm going to put the A, B around it, and I'm having to do three letters because D has actually two angles at it, so we have to make sure we do the three letters so the person will know which way to put the loop. And the other one is, the double line is B, is it in the middle, so B goes in the middle, and DC goes around it. And those are called alternate interior angles, and we call it AI. But when you write this for somebody else, make sure you put the whole words and not just the symbol. Those are alternate interior angles. Now that we have those alternate interior angles taken care of, now we can say that triangle ABD is congruent to triangle CD and B. And I'm going to check my letters, make sure I'm right. A match C, B matches this D down here, and this D matches this B up here. Okay, and we have angle, side, angle. So they're congruent by angle, side, angle. And then, now we're back to what we know. Since we proved these triangles are congruent, now we can go and say the fifth is line segment AB is congruent to line segment CD by CPCTC. And we're done. And we just proved that opposite sides of a parallelogram are congruent. And we're finished. Okay, let's go ahead and go to the next one. All right, now this one wants us to prove that AD and BC are congruent. So that's what we're looking for. I'm going to put question marks there. It says in the diagram, ABC is a parallelogram and BD is a diagonal. So if this is a parallelogram, then I know these two sides are congruent. I know that I'm dealing with alternate interior angles. And I know, I left something out in the other proof. I'll go back in a second. So here, I know they share this side. Let me go ahead and fix that. Let's go back for a second, guys. I left something out in the proof. What I was supposed to say here is before I can say anything about these triangles being congruent, I left out something. All right, let me show you what I left out. I left out that reflexive side that they both have in common. So I'm going to erase this. And it happens. So for number 4, we need to say that BD is congruent to BD, and that's from the reflexive property. All right? So erase and fix your paper, please, or if you already had it on your paper, I'm sorry, sweeties. Okay, now I can say triangle ABD is congruent to triangle CDB by angle, side, angle. There we go. And remember, you always have to write down everything that you added based on your logic that you know to be true. And then 6, we're going to say, therefore, AB is congruent to CD by CPCTC. And now we're done. Okay, sorry, babies. Let's jump back into this other one. So let's finish what we were marking up. So we already know that they share this side. We have the alternate interior angle. So now we just write our proof. Statement. Reason. So number 1 is the given, and we're given that ABCD is a parallelogram, and I'm writing shorthand, and BD is a diagonal, and that is the given. So number 2, we need to go in here and we need to start breaking stuff down. We're going to say, and it doesn't matter which order you put your information in as far as breaking your things down. Just make sure it's all there. I'm going to start with the alternate interior angles first. I know that the measure of angle ABD is congruent to the measure of angle congruent to the measure of angle BDC, and the measure of angle AEC DB is congruent to the measure of angle, and the other loop is right here, so we have B and DC goes around it, so DBC, and that is called alternate interior angles. And number 3, I'm going to go ahead and say that BD is congruent to BD, or you can write DB, same. That's called a reflexive property of congruency. And now we're going to go here, number 4, add now we can say I have triangles that are congruent, and I can say that triangle I'm tripping. I need to add a step. I'm leaving out the parallel sides again. So I'm going to go in here and say that I'm not finna, here's what I'm going to do. I'm not rewriting all of this, guys. I'm going to go here and make this smaller so I can get that in there. Because the only way that I can say that those angles are congruent, I have to first say that those two sides are parallel. So give me a second. So these proofs are just a flow of thinking. It's probably better to write a plan as you're doing it. So ABCD is a parallelogram, and BD is a diagonal. That's your given. All right, and number 2 is we're going to say that AB is parallel to CD, and that's a property of the parallelogram. And now we can keep what we have about the rest of it. 3. I'm just going to change the numbers. So hopefully you are doing your homework and not just copying this video. You should be using this to check behind yourself. So hopefully you have already written that, and if not, it's okay. Just learn from your errors, like I'm learning that I'm missing my steps too. Should have wrote a plan first. I could have wrote all that down, then I wouldn't have forgot. So angle D matches B, so I'm going to put B in the middle, and then AD around it. 3, 4. All right, 5. Now I have my reflexive property. So I have everything flowing. I know these are parallel lines. So if I have parallel lines, then I know I have alternate interior angles with that transversal right there. And then I have my reflexive property. Now I can go and say my triangle congruency. Triangle ABD is congruent to triangle CDB by angle side angle again. And now I can say, since I got all that taken care of, number 6, I can say triangle, I'm sorry, not triangle, line segment AD is congruent to line segment BC by CPC/TC. And we're finished. All right, let's go to the next one. It says prove that angle C and A are congruent. So we're going to put a question mark right here, a question mark right here. And it gave us the same information. So now we're proving that alternate opposite angles are congruent. So we're going to say statement, reason. Okay, number 1, ABCD is a parallelogram, and BD is the diagonal. All right, I'm going to start right here and start marking up this picture. And this is the given. Okay, let's go ahead and mark what it gave us. I know that I need to prove those question marks. Well, here's what I do know. These are parallel. This angle is the same as this angle because BD is a transversal. And I know this angle is the same as that angle. I know these two are they're gonna share that side. So I see my congruent triangles in there. And so I got it. So as long as I can find some congruent triangles, we are in the game, babies. Okay, so let me get going again. So number 2 tells me that AB is parallel to DC. That's property of a parallelogram. And I'm writing shorthand, guys. Number 3, I can say that if these are parallel, then I know BD is a transversal. So I can say the measure of angle ABD is the measure of angle BDC, and the measure of angle ADB is congruent to the measure of angle DBC. And those are alternate interior angles again. You guys are probably picking up on a pattern here. And number 4, I can now say that BD is congruent to BD from the reflexive property. And number 5, reflexive property. Number 5, now I can say triangle ABD is congruent to triangle A should match C, this B should match that D down there, and this D should match this B up here. And that's going to be by angle, side, angle. And because we have that going on, now we can go and say number 6 is going to be the measure of angle A is congruent to the measure of angle C by CPCTC. Because once we prove one of the congruency statements, all the other parts fall right in line. All right, let's see what we got next. Oh, and we're finished, guys. All right, see you on tomorrow. Hey, start working on your summative review. That'll help you get ahead also. Bye, guys.